Okay guys, welcome. So this is the third video into this I think this playlist. So today we are going to be looking at AWS Lambda. So I think we started up with the EC2 Elastic Compute Cloud, and we also looked at the simple storage service, and today we are going to be looking at AWS Lambda. So what is AWS Lambda? It's a serverless computing service provided by Amazon Web Services, AWS. Now, when it comes to EC2, right? When it comes to EC2, the Elastic Compute Cloud, there's one thing you need to know about it. How is the computing being done? How is the computing being done? We deploy servers, right? We deploy virtual servers. That's the aspect of virtualization, so that we might be able to get once our servers are online, we can be able to host, you can be able to perform other things. So you're actually using compute engine, servers and everything. But this particular AWS Lambda is a serverless computing mode, service. This is mostly done to simplify the way let's say the underground architecture lies. Now let's say you are actually having an application, you want to deploy it, right? Okay, let me say, for example, if you are a Flutter developer, you have developed a Flutter application which is quite functional, everything is going on. But you know that in order to deploy this particular application, there is so much setup which is required. First of all, you need to set up your Android, your SDK, your software development kit. You need to configure all of those. But to some extent, most devices are not compatible with all of these, let's say, all of these requirements. So sometimes it becomes a bit difficult. That's why with the aspect of serverless computing, this can easily solve issues like this, whereby you just need to deploy the code, and the AWS themselves, AWS Lambda for example, simply sets up the required environment for you without you having to manage any servers. So that's why we talk about serverless computing. So you do not have to bother about the underground line architecture infrastructure. You just need to know that you are deploying your code. Yes. So it allows developers to run their code without provisioning or managing servers. So there's no time where you have to go and get some servers. Maybe you're checking up, working with servers. No, you just need to know that once your code is running, the AWS themselves, they take total responsibility of managing how it operates. Yes, so maybe if there are certain servers which are required, the system automatically sets them up. Now, AWS Lambda functions are event driven, meaning that they are executed in response to event or triggers. So this particular one is, now let's say for example we have an S3 bucket, right? We have created a bucket in our simple storage service. You can create it in such a way that perhaps when we talk about events, this could trigger reactions. Events are simply, let's say, in fact, anything that could trigger a reaction on your AWS. So especially when it comes to simple storage service, you can set it in a way that whenever someone, let's say, perhaps uploads or updates the bucket, there is a response to it. So maybe you deploy code, what happens? You can get a real-time response. So all of these they are always automated. You can set it in such a way that, okay, perhaps let's say you are running a website, right? Yes, you can also use this service. So specific implementations are just used when it comes to real life cases. Perhaps you have, okay, let's say perhaps there's a certain there's a certain app you want to deploy. Let's say for example there's a certain app you want to deploy and be able to make updates to this particular application, right? So once maybe the app is already running, once you publish the code, it actually needs to make this update. So actually, due to the serverless computing aspect, it's going to automatically do this update without actually having you to bother about let's say all of the provisioning of resources and everything. Now, here are the technicalities and features of AWS Lambda. So these are the things that you must know. Now, we have what we call a Lambda function. A Lambda function is the unit of code deployed and executed by AWS Lambda. It consists of the code written in supported languages such as Python, Node.js, Java, C#. Yes, so now as I said, you are basically deploying a certain code, or let's say it's actually executing a specific code which you have put. So let's say you have coded an entire application in Python. in Node.js, as you see there. As I gave the first example, we have Flutter. So depending on that, you code all of these. You can now use AWS your Lambda function now to deploy it without having to bother about allocating resources and servers. Event sources, very important. Event sources triggers Lambda functions. They can also include services like Amazon S3. So I'll give you an example of S3. We have DynamoDB. That's a database service. DynamoDB is a relational database service. We have Amazon Kinesis. So that's another one. We are going to I think we are going to have a brief highlight on these other ones: CloudFormation, API Gateway, and more. So what is a handler? What is a handler? A Lambda functions handler is the entry point for the code execution. So what does this mean? What does this mean? Now, whenever a function, okay, let's say whenever a Lambda function is triggered, right? We said it could be triggered by an event, and we have given you what sort of events could actually trigger it, the event sources. Now, the handler now is what actually takes part in executing the code. That's why we say is the entry point of the code for execution. So it's very important. So in the moment you have the code running, the event handler now, the handler now is the one who actually executes it for you. So it's a method or function within the code that AWS Lambda invokes when the function is triggered. The handler receives the event data and context object. So once you have deployed it, once it is triggered, once the event has been triggered, the function has been triggered, what happens is actually the handler executes it. Now we have execution context. Remember, the handler receives the event data and the context object. So now we are going to try to understand what's the meaning of execution context. The execution context here provides more information about the runtime environment of a Lambda function. Sorry. Now, what do we talk about the runtime environment? Now, since we've said that we simply have a piece of code, right? Yes, we simply have a piece of code. Now, how does AWS Lambda actually identifies what language, let's say what requirements are needed, all of those? That is what we talk about the execution context. Yes, the requirements which are needed to set up that entire environment in order for the code to be executed. So it includes details like function name, version, memory allocation, and request specific information from the code. So after you get all of these, get the specific details of the system, it can now be able to launch to you, allocate to you all the resources that you need in order to get that particular function executed. Now we have triggers. Triggers are almost let's say, okay, triggers are almost like events. Triggers define the events that cause a Lambda function to execute. Yes, triggers. So now what happens? Immediately something happens, there is a trigger. What does the trigger do? The trigger actually defines an event. Yes, the trigger actually let's say it stimulates an event to be executed. Yes, so they can be configured to react to data changes, scheduling based events, or API requests. So for example, let's say you're having a website and a user wants to upload content to it, let's say via your website, right? You have included a panel there whereby users can be able to upload content and everything. Now immediately someone wants to upload content, they are doing it from their front end, the interface they can actually interact with. So immediately this is done, it goes up. Now a function needs to be executed. Okay, this is what wants to happen. Your application needs to be able to handle this specifically. So this information now could go immediately. It gets immediately now it gets to the host. Immediately this request is placed. Now a trigger now could trigger now the specific function that is meant to handle it. So it could actually trigger the event that is meant to handle it, right? So immediately it's handled. Now we can actually get the feedback we want. So that's why we talk again about serverless computing. You do not need to bother about its underlying architecture infrastructure. No, you just need to bother about your code. So you need to write your code, but please ensure that you are writing something reasonable. We also have concurrency. Refers to the number of function instances that can be simultaneously executed. Okay, so we all know that since these are various since we have different events that could be triggered, sometimes you may never control how many events can be triggered at the same time. So depending on what is the setup of your system, sometimes different functions could be triggered maybe by different users, different API requests, and sometimes it could all handle simultaneously. Sorry, happen. But concurrency now here refers to the number of function instances that can be simultaneously executed. So at a particular instance, how many functions can be scaled up, right? Automatically scales up depending on the incoming request, depending on the incoming request rate. So but this is where these are okay, depending on this particular one now entails if you can actually give the permission, because sometimes perhaps you may set your fixed size. You may also want it to be limited, unlimited, like it should automatically scale up. Yes, so it's good. It's a great idea if it automatically scales up so that you do not have to really bother about that. Now, invocation is the process of triggering a Lambda function. Invocation, so once a trigger occurs, it triggers actually an event. Now immediately it is triggered. Invocation is a process of triggering a Lambda function. So invocation is, let's say, starting its execution, something like that. So it's actually all of them, invocation, trigger, event, all of them still talk about one thing. Now it could be synchronous or asynchronous. Synchronous invocation waits for a response, while asynchronous invocation returns immediately after the function is triggered. Now there's a concept of, let's say for example, if you are from a programming background, right, you hear about synchronous programming and asynchronous programming. What's the difference between synchronous programming and asynchronous programming? When you are working with synchronous programming, you actually let's say for example you place a request to an API. You need to wait for the request, let's say for the result before you can actually proceed. But for asynchronous, it could be going on at the same time, so you do not have to really wait for the other request to be finished. No, you can actually perform all of those at the same time. So asynchronous events often are very important when you are handling future events. Okay, so features of AWS Lambda. We have flexible compute. AWS Lambda allows developers to focus on their code without worrying about infrastructure management. This is what I've been telling you about. It automatically provisions compute resources and scales them based on demand. Very important. So you do not have to bother about infrastructure, your servers, computers needed. No, you just have to bother about your code. So it is actually very, very important. And also this aspect of automatically scaling up the resources and servers, right, in order to meet up with the requirements of the system. So it's very important. Pay per use. So depending on the usage, so that's why users pay only for their time consumed. So that's compute time, right? That's compute time that their function uses. So immediately they deploy their functions based on its usage, based on its compute time and everything. That's how much they pay. So they do not just get to pay, let's say, for a very high amount or low amount, maybe static. No, it's depending on how it is. For example, let's say I'm running a website which is basically running by AWS Lambda. I'm running it, right? Now, depending on the way I've actually set it up, if I actually just, let's say I use my own service, let's say outside of AWS. Now, most of the time you need to, let's say, purchase some, let's say, host. For example, if you want to host a website, you will need to purchase this hosting plan. And most of the time, let's say your website is not popular yet, it's not generating any traffic, so you notice that you are using a whole lot of infrastructure for something that's not yielding any results of the moment. Yes, so when you use our services with AWS Lambda, pay per use is a very important aspect. So you only get to pay for what is used. So let's say perhaps there's no traffic and all of those things, the compute time is, there's no much resources being used, definitely your pay is going to be to the lowest. Now, event driven architecture. So this particular one, you do not always need to, let's say perhaps you do not always need to interact with it, right? So the moment you set up your event, it's automatic. So AWS Lambda functions are designed to be event driven. They can be triggered by various AWS services, allowing developers to build serverless applications that respond to changes in the system. Yeah, it's very important. So let's say you are getting websites done. If you want to build a certain system and application, okay, let's say if you want to build an application, you're actually using an S3 bucket for data. You may be using DynamoDB for maybe database. Maybe when a user creates an account, you can set up functions that immediately maybe an account is created, it triggers an event to happen. Maybe perhaps it releases a notification, all of those things. Yes. So you can also integrate with other AWS services, as we said earlier, AWS services like S3, DynamoDB, and we have things like EC2 sometimes, Amazon Kinesis. Now it enables developers to build serverless applications that leverage the full AWS ecosystem. Yes, the reason is because now most of these things actually since there are so many systems, right, we have things like SageMaker. Now when all of these different services are done, remember the primary aim of it is to be event driven. So immediately something occurs, perhaps you may want to respond to certain changes within your system. So when you use Lambda functions, you can actually handle them. So the Lambda functions are not actually static. They are simply a set of commands that you may have programmed to occur due to maybe some event that has occurred inside of your system. Now we have versioning and aliases. Lambda functions can be versioned, allowing developers to manage different versions of their code. Yes, I think that's pretty understandable. Aliases can be used to point to a specific function version, enabling controlled deployments and canary releases. Now, when we talk about aliases, now since there are different versions, right? Each version could be called an alias. Yes, each version could be called an alias. Let's say, for example, if you have a certain function, you have version 2, version 3, you could call them aliases. So environment variables can be used to configure Lambda functions. They allow developers to pass configuration values to their functions without modifying the code. It's very important, very important. So you can often, now the thing is now since your system, perhaps we have said it's all about serverless computing, right? It's all about serverless computing. So what that means is most of the processes are automatic. They automatically set up the infrastructure and everything. So what happens if you want to actually be able to influence it, they are what we call environment variables. So you can often pass in your own configuration values depending on what you want, and it actually influences the system. Yes, so it gives us the possibilities of that. We have logging and monitoring. Logging is the ability for maybe perhaps you receive feedback based on it's running, so you can be able to get certain matrices about it. Let's say maybe there's a crash, something happened, it did not work, or let's say for example you are running your website specifically, you want it such a way that whenever there's an error, it should actually be able to log it, keep it somewhere so that you'll be able to see. Maybe you want that whenever your website is down, it should trigger a notification. You use AWS Lambda. We have VPC support. VPC is a virtual private cloud, right? VPC, virtual private cloud. I think we are going to get into VPC, maybe perhaps the next, or if not the other one to come. So VPC enable us to access resources in the VPC virtual private cloud, such as databases, caching services. So this is most of the time this is networking. Yes, so to connect to different networks and everything. So limits and configuration. Limits and configuration. Firstly, we have memory allocation. Now, when creating a Lambda function, developers can specify the amount of memory allocated to the function. Very important, very important, very important. So more memory allows the function to perform better, but also affects the cost. Remember, the aim of this thing is to remove the aspect about servers and everything. So it's basically serverless. So the moment you allocate a certain memory to it, automatically scales it down to suit the memory that you have done with it, that you have allocated to it. So it automatically is going to function in that way. But as I said, it's not really a good idea to allocate low memory for your function. The more memory it has, the more efficient it becomes, right? Yes. So but whenever you have low memory, it's often there are certain restraints that are passed in. Yes, there are certain restraints, so it can never be as effective as maybe perhaps you're using high memory. Yes. So timeout. The maximum amount of time a Lambda function can run is configurable. Yes, by default the timeout is set to 3 seconds but can be increased to a maximum of 900 seconds, 15 minutes. Okay, so this is when it comes to deploying your code, right? So deploying your code immediately, let's say you have deployed it, maybe the code is running, certain things. So we'll talk about timeout. So perhaps let's say you have deployed a certain function, it's supposed to happen and it's taking a very long time to occur, very long time. So sometimes there could be errors in the way and everything. So they are basically saying that this timeout is the maximum amount of time that it could be disrupted, right? So immediately this time reaches and maybe what you are doing is not over, it's going to be terminated. Why? Because it's it has reached timeout. So environment variables, Lambda functions can have environment variables that can be accessed by the function code. These variables can be used to store configuration values or any other data required by the function. So as I said again, environment variables, you can be able to specify specific configurations for your functions. Now, dead letter quiz. Dead letter quiz can be configured for Lambda functions. If a function fails to execute successfully, the event can be sent to a dead letter queue for further analysis or processing. Now, this involves a case. For example, we all know that not all Lambda functions will be executed successfully. There are times where you may not probably have an effective internet connection to be able to, let's say, get it up and running. Certain times there may be errors with your code even. So whenever things like that happen, we have dead letter quiz. So automatically they are passed in here so that they can be further evaluated, right? So you can always know, so you can always be able to check, okay, what was wrong with this, since this did not go through, maybe perhaps there was an error. This is for debugging purposes, so it's very important. So we have reserved concurrency. We spoke about concurrency, the amount of concurrent or simultaneous functions that can be executed per instance. Now, AWS allows setting reserved concurrency for a function. It ensures that a specific number of function instances are always available to handle requests, even during periods of high demand. Now, we have spoken about the fact that concurrency use, specifically Lambda functions, have a limited concurrent rate, right? So instances cannot run all the time like simultaneously. So what happens, this reserved concurrency actually now allows reserved, let's say it actually reserves some concurrency such that it actually provides a reserved space for certain functions to execute. Let's say, as you see, in times of high demand, they can always create this additional available reservations for your functions to be executed. Now, deployment and versioning. Deployment packages. Lambda functions are deployed as deployment packages, which can either be a zip archive or a container image. So when we talk about a zip archive, now once your function has been written, right, immediately you have executed your function, you are going to have a result, right? Let's say, for example, if you wanted to deploy an application, you execute a function that actually does all the code and everything. You can store it as a container image. What's a container image? Okay, this could be, most of the time when we have things like Docker. I don't know if you've ever heard about Docker, but when you let's say, dealing with things like Docker, where you have pre-set up configurations already taking place. So this is actually very best, especially when you want to set up containers. Yes, we want to set up containers. This is for I think the area of DevOps. Yeah, this is for the area of DevOps. So there's also what we call ECS, right? So when we are going to be seeing ECS, elastic containers, so we are going to be actually relating them. So I'll talk about a deployment package. Whenever you deploy Lambda functions, after they are being executed, they can be deployed. So after you deploy it, it becomes a deployment package with all the configuration settings and everything. So immediately you execute it, you can now be able to deploy it such that all of the services, the servers and everything, the resources that were allocated can be now copied, created in the form of an image, so that that particular piece of code you can always execute it on other environments. Yes, so it holds all of the settings and everything. So the reason is because maybe perhaps you may want to execute this particular stuff with the specific settings, so you are always free to do that. We have function versions. I think we have spoken about versioning. Now aliases point to specific versions. We have spoken about it, I think. Now we have integration and event sources, right? So let's look at some major integrations. We have even spoken about them. Now, API gateway integration. AWS Lambda can be integrated with Amazon API gateway to create serverless APIs. API gateway acts as a trigger for Lambda functions, allowing them to handle incoming API requests. Now, let's say you're having your application, you are using an API. You are using an application programming interface inside of your application, right? So you are connected to an Amazon servers by virtue of API. So let's say you are using the S3, you are using the simple storage service, perhaps for a purpose which is intended by for your application. Now you can set it in a way that whenever perhaps something happens, or there are specific, one of the best ways I actually interact with this is when it comes to notifications. Whenever you are working with applications, web applications, the reason is because most of these applications at times need to be able to send notifications on specific triggers. Yes, so you can set it in such a way that once, now one of the first, let me give you an example. For example, whenever I used to build website, let's say with Flutter, Firebase, right? So immediately you can set it in such a way that whenever a new document is added to your database, what happens? It triggers a notification saying that perhaps a new document has been added. You can go and view it. So these are the functions of notifications, and all of this can only be, let's say, be done using functions. So you can often configure the functions, or let's say we have aspects like WhatsApp. If you are using WhatsApp, if you are using a WhatsApp status, right? You often notice that most of the time people have statuses, and to some extent they will just disappear after 24 hours. You think they configure it? No, they set functions that as these things are available after 24 hours. So that's a trigger. Immediately after 24 hours, what happens? It automatically deletes it. So they have set up the function to delete it after 24 hours without your control. So there's no way you can actually control it. Why? Because actually a function that is actually doing that. So event sources, we have looked at different event sources that can that we can work with. So Amazon S3, DynamoDB, Kinesis, SQS, SNS, CloudFormation, CloudWatch. So these are other services that Amazon offers. Now we have custom event sources. Developers can create custom event sources using AWS services like CloudWatch events, step functions, or by implementing their own event source using AWS SDKs. Now, these are ways whereby you can actually define your own events. So I think that's kind of understandable. So you can often customize events sources. So you can set perhaps, let's say you have a specific event that you want to occur, you have a specific function that you want to occur. You can set up your own event source such that maybe it listens to this particular source maybe for a specific change, and it reacts to it accordingly depending on how you want it. So these event sources, you could set up maybe your own local machine for it, you could set up your application for it. So that's dependent on you. Now, monitoring and error handling, CloudWatch logs. Yes, so AWS Lambda automatically captures logs generated by the function and stores them in Amazon CloudWatch logs. Developers can view and analyze these logs to troubleshoot issues and monitor function behavior. So this is actually very important. So while it is running, it's able to take in all the logs. So in case there are errors, in fact whatever is happening upon its execution, it logs everything to your CloudWatch log. Now we have CloudWatch metrics. So CloudWatch, remember, is meant to monitor your entire AWS while you use it, right? Now CloudWatch metrics. So AWS Lambda provides various metrics in CloudWatch that can be used to monitor the function's performance, invocation count, duration, and error rates. So this is important so much because, especially in the long run, whenever you're dealing with a business, there must be a method of accountability, method of matrices, such that you can be always able to account for, let's say, its usage. So you can be able to, perhaps there are certain times certain errors originated because of this, an error was originated because of this. So what happens immediately? You are able to get the matrices. You can always be able to compare. So this is to improve on productivity with productivity. This is for business perspectives. X-ray integration. AWS integrates AWS X-ray, a service that helps analyze and debug distributed applications. By enabling X-ray integration, developers can trace requests through the Lambda function and identify performance bottlenecks. Now what is this? What are distributed applications? Now let's say perhaps I've created an application, I've deployed it on the cloud, and different people are using it, right? So you come, you connect, and you are able to use it, perhaps. So as immediately you are actually using it, it's like now you are using a distributed form of it. Now while you are actually using it, we have things like let's say we have things like XAMPP. Those are distributed systems. So immediately you are using them, immediately you are using it. Now you can always be able to track different, maybe perhaps there's a crash here, there's an error here, and everything. So immediately things like that happen, it triggers a function, logs it back to AWS, such that you can now be able to actually get it. So actually servers like that are actually deployed from the cloud and are distributed all over, such that you can be able to use it. So these particular services, since they are used by multiple diverse individuals, logging their content, being able to hold certain access to them is very vital. Error handling. Functions can handle errors by returning appropriate error codes. So this is an example of Lambda functions. I think when we are doing the practicals, we are going to see about this. So in order to send a hello world message, let's say this is with Python. So def lambda handler, we give an event, we give a context. So it's supposed to return our status code 200 body hello world. So that's a very simple application. Yes. Image thumbnail generator. So generates a thumbnail image whenever an image is uploaded to an S3 bucket. So let's say, for example, if you want to upload content to YouTube, automatically you can notice that a thumbnail is automatically assigned. So these are certain things that could be powering them. Import Boto trace, all of these ones. Now this is if you are dealing with this specific sector, but as I said, it's almost impossible for you to know all of these. So if you are working on a system architect or solutions architect as an AWS developer, you must have basic knowledge of all of them. You must have basic knowledge. So I think that's the end. We're actually going to have a practical session. So thank you guys for following up. I'm Nebota Ismail. So I think we are going to continue again next time.